Good afternoon, everyone. Let's start. So, yesterday our talk was on explainability and transparency in AI, and today we'll continue with a different topic on AI, and particular AI privacy, accountability, safety, security. And our lecture today will be given by Dr. Magnus Westerlund, who is principal lecturer at the Arkada University of Applied Science in Helsinki, Finland. And he will give us some insights on privacy in AI. So without further delay, I will give him the floor.
Thank you very much, Tor. Hello, everyone, and thank you for having me on this lecture series. It's been quite an interesting journey you've had so far. I've followed quite a few of the talks as well. Today, like we already heard, we will talk a bit about what we mean by trustworthy AI, what we mean by safe AI, and we will touch upon things from an AI perspective mostly, and try and figure out what is the difference between AI solutions and what towards traditional IT systems. And the question, of course, is that can we create trustworthy AI, and what would it mean? So the trust itself tends to be a property that is really hard to define. For technical purposes, we usually either consider we have trust or we do not have trust. But as we know, trust in societies is quite different. We have different levels of trust, and this is a bit hard for sometimes in computer science to really deal with. So in computer science, we usually think of it as something that is more or less black and white. But I think that this is going to have to change a bit, perhaps for AI, because it's going to be really hard to have a completely trusted AI, and perhaps we need something here in between. Are there any useful design guidelines? You have had so far quite high-level discussion on the ethical concepts, and unfortunately missed yesterday's lecture. But the basic idea here, I think that this talk will have, is that you have now already understood the way the ethical concepts are influencing our design decisions. Now, I want to more stress the technical considerations as well. Of course, I know that some of you may not have a computer science background, so I will try and still keep the discussion on a level where you can all follow, so to say. The solution is not, of course, a simple technical solution to create a trustworthy AI. It's going to require quite a lot more. It has to withstand the human touch, of course. And what is going to change, as I will show you, is that trustworthy AI will be much more about the continuous development and the maintenance process of dealing with these systems. So this is most of what we'll talk about. So, but I will start off by defining a bit what cyber safety, what we mean by that. It's for some of you it might be quite obvious, but I will try and raise some of the concepts that we kind of think that are quite important when we talk about safe technology, particularly from an IT perspective here. I will give some illustrative examples. We'll talk a bit about hybrid threats, and then we will go in more to deep on the AI safety part, and try and figure out what type of heuristics do we actually have available that we can use. but this is quite an interesting field, and I think that for anyone that is in computer science and think that computer security in general and AI are interesting concepts. Here with today's talk, I hope you can gain some ideas of what you can write your thesis about. This is a fairly open field still. It doesn't really have a very firm structure yet. So there's not really any specific conference, for example, that is being organized for the security for AI, so to say, that would be particularly in that field that I know of, at least. And so I think it's quite a fruitful area for further research as well. But let's get in a bit to cyber safety. I will, during the lecture, I will stop about halfway through, and then you can ask some questions, or we'll moderate those, and then we can at the end as well have some questions. There was an interesting book coming out from some Google researchers recently that I can strongly recommend to anyone that is in computer science, and particularly for those that have an interest in security and reliability. That is creating kind of safe solutions, IT solutions, systems. And I think what this book is giving us is a framework for how Google is working, and of course on their scale, it's really important that security is shown all over, so to say, the place. It's not so that we can have a separate security organization that comes in every time there's a problem. That of course would really create an issue that would more or less harm Google's business model as well. So in this book, you will find it's quite a large book, actually, quite a big book, and it goes into also the human perspectives on security. So in that sense, it's a very holistic view into what security is. So it talks, for example, also about the organizational demands on when it comes to security. So this is something that I can strongly recommend this book for you guys, and it's free, so it's perfect as well. There's two concepts that comes up: reliability and security. And as we know, these are emerging properties. These are properties that we cannot really state that we have. We can show after a while that it seems that our systems are secure. It seems that they are reliable, but it's not something that we can definitely state in that sense. And I suppose that this is for all technology, if you think about it. This holds for most cases that you can think of. So reliability and security, these are the two topics usually that we try and teach security from. There are differences between these two. So for example, the reliability focus quite a lot on integrity, on availability, of course, and to a certain extent, at least today, on confidentiality. These are perhaps not necessarily security issues that needs to be dealt with, but of course there are similarities here. But there are also some very similar things here that we can think of, and here we have the problem usually of both aspects, both properties, is that they are rather invisible. So for an engineer, you have a fairly well kind of a fairly good idea of how you can design a system so that it's reliable and secure. But from a business point of view, the definition of reliability and security are really hard concepts to understand. So once the security is breached, it's easy to understand that, okay, now we have an issue. but to actually put money into security is something that is maybe a harder decision to make. So unfortunately, often in many organizations, security is something we add on at a very late stage. And of course, for those of you that have been in computer science know that this is a recipe for destruction, and it's going to fail you one way or not on another. And this is really what the book is all about as well, that we need to view these concepts, building safe systems from a more holistic kind of point of view, that business must understand the importance of building secure systems. But this is the invisibility part, and then we have, of course, the assessment part. Both of these can be assessed, and we have different protocols for assessing secure systems or security in our systems. Depending a bit on what company you would be working for, you may have different protocols that you would follow. And then you have simplicity versus evolution. That this is another problem that we have with IT systems. We have something called legacy code that we usually don't want to touch. So you start off with an ideal that you create a very simple system, a system that you can test very thoroughly, that you understand all the complexities in. You don't have too many so to say abstractions that don't allow you to completely understand your system. But then when the system itself is going through an evolution, you keep on adding features, you keep on changing or things, you will have what we then refer to as the legacy code, that we don't really want to touch perhaps certain systems because we feel that they have more or less rotten from within, and if we touch them, we are more or less afraid that this old code will kind of explode in our hands, in a sense. So when you look, for example, today at the banking sector, they still are using software from the 60s. COBOL programmers are still needed in the banking sector. We haven't taught the programming language COBOL for 80s, perhaps, since the 80s, as far as I know, at least. So it's something that we have to think of, and unfortunately, most of the IT industry and the development sector really thinks about the innovation. It's really hard for I think most startups, for example, to think about the long-term implications of the design decisions that they do. This is something that you eventually then wake up to and realize that, oh my, did we actually enable that? Here, of course, I'm thinking of companies such as Facebook and Cambridge Analytica, that they created a very, very nice solution, and then there was someone else who came in and, I wouldn't say attacked the system, but at least from within they were able then to utilize designs that were perhaps not supposed to be there in the first place. So this is something that we have to think about, and these emerging properties, they of course will be very important as well for AI. And if you now think about contact tracing apps that for example have been proposed by both Google and Apple, I think this is also something that illustrates a bit the difference between security and reliability. I would assume that the engineers for both Google and Apple understand how to create secure software, but reliability goes a bit further. It has to do with the use of these apps. So would you actually at some point lose your privacy if you were to use these apps and you would be tagged as having the virus, the COVID virus? So I think it's it's a very hard topic to get into. In technology, we usually focus on the security part, and then we hope for the best with reliability. But I think that most people today are starting to realize that computer security in itself is not enough. We need to have a holistic perspective of what we mean by safe systems. And here reliability, of course, is something that must be included as well. If we look at a brief history of security, this perhaps helps us more to understand where we are heading. So we started off with client security and data security. So client and data security introduced the ability to separate users, and then data, of course, that the data we were working on, that we could keep that to ourselves. So confidentiality in that sense. Then we had network security coming up with the internet. And then, of course, when our mobile phones were becoming more important, we had that field as well. And in the last 15, 20 years or so, cloud security has become a really interesting topic for research. And nowadays, of course, it's also something that is quite important for companies. A new research field is perhaps the distributed security part. Here we had a big breakthrough with, of course, the Bitcoin. When it was launched, it gave us a new idea of how to do what we refer to as trustless transactions, meaning that we have two parties that can do a transaction without actually trusting each other. So instead of then having a third party there in between, for example, a bank or something else, we can now directly transact between party A and party B. So security is something that has evolved. It usually focuses on the application. So security by itself is now perhaps longer existing as a field by itself. It used to be perhaps more like this. If we go really far back, we had a very strong applied mathematics focus on security. But today it's much more than that. Then we have the new one, AI security, or security for AI. And what will that mean? As I said, this is a field that is still forming. We don't know if it's going to be its own field or if it will be a subfield. I would suspect that if it's a subfield, it would go under distributed security eventually, but it might as well become a field of its own. Only time will tell that. But the traditional software stack that we have tried to secure is an OS, a network, and an application. And only when we have all these parts secured, we can at least with some certainty say that our system has a certain level of security. So this is basically the issue with security, that if one of the parts one of the links in the chain, so to say, is weak, we do not have a system that we can trust. But now when we're looking at distributed security and AI security, of course, the software stack is changing. It's constantly changing. So this is something that we will need to rethink. Maintaining confidentiality, we have quite mature tools for dealing with this, both tools and processes. We have identity and access management. They are usually focused on the centralized control aspect. So a trusted party can add or remove the trust, so to say, downwards, and this allows them then to either accept you into the network or kick you out of the network. To deal with confidentiality, or to improve rather the confidentiality, we can add different multi-factor authentication methods, and today it's become quite quite important to have these. But as always, usability is the most important part. So security and reliability in general is always depending on that people actually follow the protocols quite strictly. So if people want to try and find shortcuts, it means that our processes will most likely also fail. And this is what often happens. I'm sure you have, those of you with a computer science background, you have all heard about the different cloud storages that are used, and then suddenly someone finds a public IP, maybe behind a certain port, and then they can access the data, and often it may even be unencrypted or even unhashed, so to say. So these are the issues that it doesn't much help if we lock down the database if someone makes a copy just for making it easier to do development for a certain feature, and then forgets about the blob somewhere, the cloud blob somewhere. So following process is quite important. Data management and security. We got the GDPR, as you probably all know. From a technical standpoint, I would say the GDPR, the regulation in itself was not much of a change. So for those companies that followed the previous directive, they more or less did not really have to change too much. So the main change here, of course, was on the business side, that where our governments now could fine companies a significant amount of money. And this, of course, led to that many companies realized that, oops, they may have to rethink their data use, or the use of personal data. But there's one thing that came that with the GDPR, and that is of course quite important, and this is the privacy by design concept. And here, of course, the basic idea is that you only store the data that you need, that you really need at the moment. So you're not supposed to store things or store data, personal data that you may need sometime in the future. At the moment, you should only store that data and collect that data that you need at the moment. For AI solutions, this is, of course, somewhat troublesome. We know that they are data hungry. They want to have access to more data. And once we learn how to kind of tweak our models, we may add new features, and those features are based on some raw data. So here we have a situation where the GDPR is really going in a different direction from what we would need in terms of improving our AI services. So, and of course, you should also use some sort of privacy preserving method. This is as well a similar kind of issue with training data. You want to have as specific data often as possible. But here the basic idea is that we try and preserve privacy even if our data would leak out somewhere. So privacy by design steps, I think we can summarize them somewhat like this, that we need to do an impact assessment. So you have a privacy impact assessment that you perform on your system. You have minimizing your data use in itself. You use appropriate security. This appropriate security was unfortunately not defined. So here we don't really know what is required. It's something that I assume that they wanted to define in a different legislation that came shortly after the NIS directive, and but unfortunately that was only applicable to certain infrastructure companies, and it's also on a very high abstract level. So we at the moment it's really hard to set a certain level of security and be sure that you actually follow the GDPR. You can make an assumption that any security would be enough, but this is something that would be evaluated most likely in a court of law afterwards. So here's something that we should really perhaps rethink now when it comes to an AI regulation that they are thinking of, or legislation, I should call it. So far, we don't know if it's going to be a regulation or a directive yet. So then we also have the authorization part that we need to identify who is using our system, and to be able to access our data, we need to always to authenticate. And then of course we have system monitoring. When something happens, there's in the beginning there was a provision for a 3-day period that companies had time to react when their system were breached. Now this was then changed to that when it is detected. So here in the beginning, I think that most companies were really afraid that they would have to be very proactive, whereas now it's become much more loose by saying that once you detect it, you have to react. So this is something that should perhaps also not have changed, but unfortunately GDPR lobbying was really effective here on this part. And then we have the continuous evaluation. So the assessment itself, it kind of connects back to the assessment that you have to go through the initial assessment that you did, and then follow up on that, and go through that. Have you actually followed what you set out, where you initially thought you were going to do? Then we have the methods for securing data. We have encryption. We often hear that you have end-to-end encryption, and then most IT people first think of client-to-client encryption, but it's rarely that. There are some legislations in some countries even for intelligence purposes that are more or less forbidding that type of encryption. So usually we have simply a server encryption. So the server encrypts our data, and the server administrator has the key to opening up. Anonymization is another one. Here we alter our data set so that it cannot be used anymore for identifying an individual. But again, anonymization is really hard on for example, image data. There's a debate, for example, currently going on if simply changing a face of a person on an image, would that be enough to say that the data is anonymized? So, for example, you can use certain types of modeling approaches to alter the face of a person in an image, and some have argued then that would be enough to call it anonymized. But if you think about it, if anyone that have been in the same position and the same location, they may have more information. So it can be really hard to argue that the data would be anonymized if someone else can then quite easily, so to say, by just viewing the image, can identify who is in the image. So then we have the pseudonymization part. Here we are trying to to change the data in a format where we can still revert back to the original form. We separate some information into a different system, and then we have wouldn't want to call it a key, but we have an ability to go back to the original data set. Then there's an argument that using such a data set would be a possibility to share it, for example, from the controller to a processor. So a third party could use the data set, and the controller would still retain the information for identifying the individual that it was collected from. So, for example, if we have medical applications, whoever hospital, for example, could collect data, and then you could pseudonymize it and send it out to a processor that would try and for example identify certain illnesses, and then you would send it back again to the hospital, and the hospital could identify who actually had that had the results, so to say. So then we have differential privacy. Here some mobile companies have been quite important in the development of differential privacy. We more or less keep the same distribution of the data, but we randomly alter the data in itself. So here we can still use it for machine learning, and this is something that some hope that it would perhaps be a way of being able to share data more easily, so to say. Then we also have something called homomorphic encryption. This is mostly a research endeavor so far. So essentially here we encrypt our data, and when we want to do a machine learning operation on it, we don't have to unencrypt, but there's only so many operations that are possible on such data, and it's also very slow. So as far as I know, there's not many practical uses of it as of yet. But the GDPR in itself, like I said, it's not really so much about the technical stuff. It's more about morality. It introduced a way of reasoning. They tried, I think, to encode a European way of reasoning. So in that sense, I think it's quite a good regulation. Of course, there are some problems with it. At the moment, for example, rethinking the concept of platform companies. Should the platform companies have a more stricter legislation? This is my personal opinion that they should have. But so, for example, when you have large platform companies that have many vertical layers of software, they are able to collect data from the vertical and then utilize in a way that any competitor without that type of platform would be able to do. So they get a rather big advantage of being able to do so. There's, like I said, there's also no direct stipulation for the level of required security. So with the exception of data security in itself and data management, we don't really talk about, for example, network security. We don't really talk about client security and all these kind of things that from a technical perspective would be quite obvious that you would need to define as well if you wanted to have a complete, holistic kind of description of what we mean by keeping our data safe, so to say. If we think a bit about the security heuristics that we have had so far, we have passive security is something that is fairly well known and for traditional systems at least. It's something that has existed for many decades already. Here we have everything from access controls to firewalls to the software patterns. These are quite established. Then what we are kind of seeing coming in now from industry is active security methods. Here we often have some sort of machine learning based detection. Of course, one of the first one was detecting spam and having spam filters, all these kind of things. But we're also seeing that machine learning can be used, for example, to try and find network attacks and so forth. And of course, viruses are as well something that you may use active security for. So then what is coming, what is still very much research is trying to figure out what we mean by autonomous security. So this is a field that is still quite young. It's developing. Like I said, this more or less started with the introduction of Bitcoin and the ability to securely do transactions between two parties without any third party in between. And this type of security allows us, or this type of solution also allows us to improve security, for example, for IoT networks. So we can move away from having the need for manual supervision, for example. We can go into a completely autonomous security here of IoT networks in the future. But like I said, this is mostly research at the moment. So here we can manage our operations through the blockchain, for example. Then we have, of course, hybrid threats coming in. I'm sure this is something most of you have already heard about. If you watched the news yesterday, you probably heard about Russia targeting Angela Merkel. And it's something that has become more or less daily news nowadays. I give here a couple of other examples as well. We don't really know exactly if these attacks occur. They may occur, but we have to remember that with the hybrid threats nowadays, it's also an informational kind of warfare going on. So the situation is really not good in the digital space at the moment. There's no real conventions that anyone is following. It's kind of fair game to attack anyone and everything, and this is making the situation quite problematic. I think quite many are expecting that the new Cold War that may come after this crisis that we are having would then be the digital war. And so I think that this is an issue that should probably be addressed on a very high level. But of course, the insight each country has into how their own companies and how they are hacking other companies and other countries is what is behind this. So when the US, for example, here is targeting Huawei, it's just a reflection of how their own companies are dealing with security and personal information. Unfortunately, as we heard from Edward Snowden, its revelations, it's something that has gone on for a very long time. It's unlikely that we are going to be able to stop it either. But so if we think about threat actors nowadays, it's more or less any group that we can think of. I listed here some of the groups. So you have individuals, both internal and external of your systems, that will attack you. You have groups of like-minded, of course, governments, state-sponsored terrorists, and of course, companies. They are quite active as well, trying to gain more information about what competitors are doing. And the challenge, of course, here is then how do they attack, and depending on the resource of the attacker, they can go further and further the more research resources they have. So, of course, the physical access here then demanding most resources. But already today, we see that almost anyone, any hacker can reach quite far up into the company chain and try and gain access or try and steal information in some way or another. So here we have a situation, I think, where most companies would try and shut down their system. They would try and create a protocol then where they would not trust anyone. So they have a zero trust policy. And then of course you can have different multi-factor authentication parts on top of this as well. But if we think more about the AI part and how that is going to change it, I think we are going to see that there are quite many new characteristics that we need to consider as well. And I started by trying to figure out what are the most prominent, perhaps, ideas that are kind of thrown out at the moment. And I went to the technology review and the MIT's technology review and just gathered four different articles in the very recent time. And up in the top left corner here, you see Google's medical AI was super accurate in the lab. So here we can draw the conclusion that quite many of our AI solutions, they work quite well in the lab. They work quite well as long as we don't involve humans. But immediately when we have humans, we start to have problems with data. We start to have problems with usage of these models and so forth. So it's of course one of the most important parts now that we have to do over the coming decade to start to evaluate these models, to test them, to understand how they actually work. Now, some would say that we need more data, but another case here, up in the right corner, there was the AI can predict how a child's life would turn out, even with a ton of data. This is a very interesting, I think, case where if it had been done in Europe, I think it would have been caught in the university's ethical board. But in the US, it went through, and I think they had several hundreds of researchers working actually on this. Is this actually the type of AI that we want to create? Is this reliable AI? Probably not. Of course, there's always value in understanding whether or not you can predict something, but in itself, it's perhaps not a use case that I would at least personally be for, that we would work on. Then in the left corner, here we can see the ability or ability, perhaps the wrong word, but the idea of trying to change policy. Here we can see how Israel is doing well, and here they are comparing against the US and saying that the US data sets from healthcare is not particularly good, and that they need different types of solutions here in the US. And in Europe, I think some of the countries, at least in Europe, have a nationalized data set. So we have public data that we work on. It's not privately owned as they might be in the US, as we have a public healthcare system. So of course they're trying to change policy, and that is of course an important part as well of trying to find new models. Then we have machine learning to check if you're social distancing properly at work. Here we have perhaps a situation where they are asking for permission, trying to see what does the public think. They're trying to get a feel for whether or not people are okay with this. So if you look in the comments, you can then go and understand what the people actually think about this. So here we have a few cases of recent use cases that of AI systems that are quite common. And if you think about the trustworthiness of these, I think it's different. And I think this is important to pronounce as well, that it's different whether or not we are coming from Europe, or whether we're coming from China, whether we're coming from the US, and this has to do with culture, I think. We have a situation where some, where at least from a European point of view, where some other countries are perhaps not really thinking too much about the individual. They are not really thinking too much about the privacy rights. Whereas I'm sure from the outside of Europe, they may think that we are a bit paranoid and we are a bit strange here, where we are not using our data for creating new business. So here is the tension that we have at the moment, and it's going most likely to continue with the whole AI development. But do we trust technology today, and how about an AI tomorrow? I think this is a fair question to ask, and this has to do, of course, with if we are up on the barricades and trying to demand control and transparency of technology. Is it possible to get it? I would assume it's not, and we cannot really control technology, at least from an end user perspective. It has become so complex, it's so multi-layered that it's almost impossible to avoid it completely. But of course, even if we cannot control it, what can we do about how to improve it? So I think that this Zoom app that we are using, I think that is one of the best examples, recent examples of how Zoom was created as a tool that would be so user-friendly that you did not need to do anything else than just click a link, and everything should work smoothly. This, of course, in the beginning, now when we had this social distancing and everyone was moving online, and the use exploded for the Zoom app, people started to complain about the Zoom app. But at the same time, most people did not really use any of the security features. They did not really understand how to set the proper security features. So here we have a situation where they were available, but people did not really understand to set for example, a password or to require a login from a third system. So here, I think it's a good example of that security in itself is not the solution. It has to include people. It has to take care of the human perspective as well. And then the question is, should it have at all been possible to use Zoom without a password or a login? That I suppose is up to Zoom itself to figure out now. But then we come into more advanced cases, more hard cases. If you have a doctor that is using an AI assistant, can the doctor actually then trust the assistant that would be trained by someone else? And most perhaps importantly, trained on a data set that the doctor has never seen. So here we're talking about experiences, right? So if there's a flaw in this data set, the doctor would more or less be still be liable for any decision that she or he may do. So then we have the big issue of trying to get some sort of transparency in terms of not only the training part, but of course also on the experiences that we have caught with that data set. So technology, I think, is and has always been about building abstractions. Maybe it will change, but at the moment it's about trying to hide complexity from users. We use an operating system today that most people have no idea of how it would work, how it works actually. So it's that is perhaps one of those software, those components that best encapsulates this whole idea of building an onion, just adding on layer by layer and hiding the complexities below, so to say. When I grew up, everyone would know what a driver is, what a hardware driver is. Nowadays, I think that most of our students, when they start off, would not know what a driver itself is and how you make a driver. This is something that has changed in 20, 30 years. So we have hidden quite a lot of complexity below, and at some point we may have to touch it again, but we try and continue by building upwards, not downwards. So this is something that traditional software have already shown us that happens. Now, if we think about the AI software, we are going to add even more complexity in terms of data and decision complexity. So here we are not just having the same issues that we had before, but over time we will have quite long kind of workflows that may be flawed in a sense. They may be biased in the workflows and so forth. And these are topics that can be really hard to detect, so to say. So I think that an AI tomorrow is likely to require even more maintenance than what we today put into our current software systems. So I think that whoever chooses to go into this field will most likely never ever be jobless. If you're good at this job, then it's a very good career I think you can have. Security is not going to disappear. It's going to be more and more, and reliability as well is going to be more and more important for the future. And perhaps more harder as well, more specialized. So how can we define an AI system? There are many attempts to do this. I don't know how many of you followed the discussion regarding deep learning during the Christmas times, during December month. There was a quite public Twitter war going on between different deep learning researchers, trying to define what AI means and what deep learning is, and all these kind of questions. And it was an interesting discussion to follow, but I think that there was no real conclusion in it. So from a consultancy point of view, any one of these would probably define an AI system. But I think from a researching point of view, deterministic algorithms themselves would not be part of an AI. Now, the AI part in itself is something that I tend to try and avoid, particularly in academia. I tend to avoid it. I understand from marketing point of view that it's much more media sexy to talk about AI than to talk about machine learning or statistics or what have you. So we have to face these terms that are put upon us, and the way to do it is, of course, is to then have a debate on what we mean by it. So we may have deterministic algorithms. We have rule sets, of course. This is something that most software would have. it's kind of hard to make software unless you have a rule set in that software. Essentially, if you have an if-else in your software, you would have a certain rule set in it. Then we have the trained algorithms. Here we often think of the connectionist approaches, such as deep learning, for example. And here we usually try to find some sort of nonlinearity. And here, with the nonlinearity, we start to get issues such as there may be some sort of unverified output space that may occur due to this. So the output from the model itself would be kind of hard to verify that it's always within a certain how should I put it, a certain threshold, in a sense, that we understand it completely, so to say. Still, most of these models are black boxes, and I'm sure you heard about this yesterday when you talked about explainability. So, and this is of course something that has gone on for quite many years, and I think this is probably the field where we still have some understanding today of how to address the model as a black box. But it's probably not going to be an end-to-end solution, I think. Then we have the interactive algorithms that we are starting to see now. These are, for example, based on different types of reinforcement learning algorithms. And here we're starting to talk about autonomous behavior or automated behavior. This is also something that has been a debate. I will come back to this a bit later. In the next slide, I think. And then there are different types of techniques here, and these techniques can again be seen as abstractions. So, for example, the ability to do meta learning, to learn basic kind of similarities between different tasks, and then can we transfer this understanding into a different environment? We may have temporal, at least sequential dependencies in this. So, for example, if you want to teach a robot to stand, they have to do certain sequences, and these sequences need to be in a certain order. So here we are getting to situations where if you want to do security and reliability for these type of models, it's becoming quite hard. It's becoming quite hard to actually define whether or not it's working or if it's not working. But then, of course, I think most researchers now, they agree that it's hard to put a single algorithm within and say that this algorithm is the only way to do AI. I think most people would argue that you need a hybrid system. So whether or not we have different types of rules or symbols, as they may often be called as well, and then combine these with connectionist approaches is something that we will have to see. So for me, I usually just simply explain AI as a learning machine without really touching too much upon what I mean by learning. But the models, they tend to show some form of nonlinearity at least, and the output space may contain values that have not been verified beforehand, and that gives us an idea of how we need to address the reliability of these systems. And then, of course, we're always remembering that model drift may occur if the representation in the data set changes. So then the distinction between the automated and autonomous systems, this is something that is, I find this quite problematic in the sense that autonomous system is something that has a fairly long history in itself, and of course automated has even longer history in it, where it comes from, and now we have more or less using these two words, so these two terms as synonyms. From a legal standpoint and from a standardization standpoint, we have automated systems. We do not have autonomous systems as of yet. So there's a kind of debate going on within the blockchain community of how can we argue that we have an autonomous system if the law does not permit us to have a decentralized organization where responsibility is not defined to a certain individual or to a company by itself. So how can the police, for example, fine someone behind an autonomous system? Now, if you take this with you into the AI world, and you have, for example, Tesla, who's talked quite a lot about in their marketing material about their autonomous driving car. From a standardization point of view, they have a automated driving car. From a legal point of view, they have a automated driving car, but still in their marketing material, and Elon Musk, he tends to talk about the autonomous car. So I think it's something that we should keep in mind. And for me personally, the word autonomous, it goes much further than just a self-operating system. So this is usually how people try to define autonomous, that you have a complex environment and you have a self operating system that can then deal with that environment. But I think that there's some early work on trying to more go into the deeper side of artificial general intelligence and trying to come up with a theory for explaining what we actually mean by autonomy. The word autonomy is something that if you look it up in the dictionary, for example, you will see that it should be self-governed. For example, it should have some sort of, there should be some sort of repercussions on that entity that is autonomous if the entity does something wrong. So here, of course, I think Joschka Bach conductor theory is one of the best requirements handling models for building something like this. But he's talking about control and the learning and the reasoning, the world model, so to say, and then selection part. I think here he gives a very interesting argument for that an autonomous device. Well, he calls it consciousness, but for me it's more about an autonomous device. Whether or not we achieve consciousness is perhaps beyond our current understanding. But from an autonomous point of view, the control part is, yes, it's one thing, but you also need to have self-learning. So, for example, a Tesla doesn't learn by itself. It doesn't learn from its own experience, so to say. And when you go deeper into the learning aspects, where do you have the self-play mechanism that we associate with trying to figure out our position in the world, for example? So we have an ability here as humans to think in terms of different scenarios, and this is something that I think is required to have an autonomous device. As just as an example, and then of course the reasoning and the selection part as well. But if we think about the automated AI, I think automated AI is what we have today, and whether or not we want to call it narrow AI or what have you, but it's still all about trying to figure out how to automate certain processes. I was quite happy with the word analytics, because that analytics for me means process, dealing with data in a certain process to achieve a certain decision. But let's call it automated AI. And if we then think about the trustworthiness of automated AI, we can find different technical characteristics that we can define. So we are starting to have a fairly good idea of where we should start to dig, so to say. But like I said, it's still a field that is very young. So trying to understand the AI privacy part, for example, can we guarantee that the methods don't reveal private information? So if we look at the GDPR, one thing that you can see that is really missing from the GDPR is what should happen to the model itself. So once you train it on personal data, have you then anonymized the data? And does that mean that when you have a trained model that it's anonymized, meaning that then you can freely distribute it? And this is really where the hard part comes in to try and regulate now the AI. Where do we draw the lines, so to say? How do we prove that we have dropped all the personal information in the model if we used personal data to train it? So, for example, if you have trained a model on images, now can we guarantee that we don't have a way of reversing that that image by running the model at some point, so that the model more or less would be able to remember what the faces were? I suppose today this is a bit out there, but still I think it's something that at some point we may have to start and think about. Also, of course, is it okay to always have to send back your data into a cloud center? Is it safe to do so? Should you use edge instead, edge computing? So, for example, we have suddenly gotten quite a lot of these assistants at home where they are recording everything what we are saying, and hopefully in the future they aim as well to record all our other activities that may occur in the home. At the same time, they are sending off our data into the cloud somewhere, and we don't really know what happens with the data. Would it then be a much better situation if we actually did the inference itself on the device without having to send it into a centralized controlled cloud, so to say? So then we have responsibility, has to do a lot with organizational responsibility and inter-organizational roles. If you create a data set and you share that data set with others, what responsibility do you have if that data set then becomes a standard for training, for example, image recognition? This is what is happening today, and we have a rather big issue with models then being kind of dependent on the same data set, and then we continue to use these same original models that someone else trained. So we don't really know what went into the models. Maybe we don't know what optimization they did within that model to get it to work properly, and then you can still use it as a developer and create your own app or what have you. And we, like I said, it's going to be quite hard to understand how these models are working if we don't train them ourselves. Maybe we don't know the data set that was used and so forth. So then accountability, we must assume that errors will happen, but then when they happen, can you actually investigate the incidents? So this is another way of again of trying to find the path. How did we end up in the situation where we are? Do we actually have a clear record of what happened? So then security, I talked a bit about this already, but I think that some of the more interesting proposals for achieving security for AI is through scenario analysis. We will talk more about this a bit later in the second part. And here the measures, of course, that we can take on the different levels of the software stack that we are using. Reliability, how reliable is the service now, and will it also remain reliable in the future? Here we have serious issues with, there's a lot of consultancy companies currently trying to sell different types of solutions, AI solutions to other companies, to, for example, manufacturing companies. Then when the data set, when the machinery, for example, is becoming a bit older, you get a data drift, you get a data representation due to the wear and tear of the machinery, and then the models start to drift, and then you need to take the consultant back in and retrain the model for you, and then you have a dependency on that one consultant maybe. Here you have a pretty big issue from a reliability point of view. If you outsource the knowledge of how to maintain the models and how to create the models, you really do not have reliability in your operations. Human in the loop. When it comes to automated AI, we always assume that there must be some sort of human in the loop. When we talk about autonomous AI, well, maybe not anymore. So, for example, if we go back to the car example, today a human must be able to take control in a situation, in any given situation, so to say. But if we had an autonomous car, then I would assume that there might be actually a situation where you could argue that the human should not be in the loop anymore. So, and then, yeah, so it depends a bit on how we use these terms, I think, the terminology. But I think we will take questions now before we continue to the next section. Toro, do you want to moderate, or?
So yeah, we have quite a good number of comments, and I have here 1-2 questions, so maybe we can have them fast. So there is one question from Alex. How secure is anonymization, and is there any possibility to restore or approximate the original data? So I think it's like how his question is, can you really trust anonymization? At least that's how I interpret it. So
I think that's a very, very good question, and I think the answer is probably no. As far as we've seen so far, it's really hard to argue that you're doing anonymization, and I think most people today would argue that they're doing pseudonymization in some form, even if they don't directly even retain the ability to restore the data set to its original form. I think it would be really difficult to prove that you have an anonymized data set.
Mm-hmm. Okay, thank you. So then we have here exactly on this slide one comment from Yvonne. Safety is missing in the screen. Is the AI system safe so that the user is not being harmed by the AI? So this is a question mark. Can you maybe comment on this?
Yeah, I would perhaps more call this reliability in that sense, that can we rely on that the AI is not causing us harm, so to say. So then we come into the usage aspect of the safety part here, and trying to understand, for example, does the self-driving car or self-operating car is it actually going to be able to handle all the difficulties that may occur? So the car itself may work very nice on California, on the sunny roads of California, but welcome up to Finland when you have 1 meter of snow and this you can see perhaps 5 meters ahead. It's quite a different way of dealing with reliability here.
Mm-hmm. Okay. Yeah, I think that these were the so there are more comments, but I think that's good for now. Maybe
Okay.
you can continue with the next part, and then at the end we will have more.
Okay. So for quite many software, we tend to create trust models, and a trust model is a way of showing that we have thought of different aspects of security, and that we have a fairly advanced view of how well our system should be when it comes in terms of security and in terms of safety in general. Today, we as far as I know, there's no clear definition for what we mean by a trust model for AI services. The challenge here is really that it's going to be quite context dependent. So depending on where we actually employ our AI, it may have an implication on the trust model as well. But for example, for IoT solutions, we can define a fairly good trust model where we can generalize based on that into different environments. But for AI, I think it's going to perhaps be a bit harder. And I wanted to open up this a bit, how we can look at it. So one of the traditional ways of dealing with security and safety in general here as well is to create scenarios, and we try and analyze a problem and try and figure out what we mean by this problem. We try to define our threat actors. We have motives. We try and set different types of methods that they can use, and of course then at the end try and define the attack vectors. And this helps us, of course, then to prepare for the worst case scenario, meaning a real attack. And so here we can then define the questions of who have access, why would they target us, and what can they do, and how can they gain access. And then you can write this down as a scenario analysis. So for example, we can choose a certain group of actors that may be interesting for this type of scenario that we are thinking of, and then we can describe them. And as I said earlier, depending on the resources of these actors, if you remember the waterfall model I showed you of how far they can go up, essentially here, so that we have a fair understanding of what it would mean. But essentially, anyone you can think of can be an actor that you need to consider. So you may need to go through all of these. Then why would they target us? There are many reasons. I think that today, of course, we still have the traditional young person who often a young boy, so to say, that is finding it quite fun to do this type of activity. We tend to call them script kiddies or something like this, that they just scan off a large number of systems, public IP addresses, ports, and so forth, and try to find a specific system that they know from before that they can target. And so if this is a technique that has been used quite long in the security, where we leave so-called honeypots open, and in these honeypots we then monitor them, the systems, and try to figure out whether or not they have been breached, and then we can learn from the techniques that have been used to breach the system. So this is something that can then be used for trying to figure out the motives as well behind certain attacks. Then you have the method part. If you again think about a certain stack here, this is just any stack more or less. If you consider that the opponent, whoever is attacking you, has the physical means and the resources to actually attack you on the physical access, it means that they gain access to the infrastructure. So, for example, if you think about the banking case here, again, this is probably the level where you have to start your analysis from. But perhaps if you are a smaller web shop, you would not have to go that far. The financial gain or the gain in itself would not be that massive, so that you could justify trying to get access, for example, to a server farm. So here again, there's something that you have to weigh against each other. Again, I want to raise this idea of zero trust architecture. This is the basic idea is that you trust no one inside or outside the organization by default. So this is something that has become quite common nowadays in security. Then we have the attack vectors. Again, if you think about an AI system here, then it can be a number of different vectors that you have in your system. It might be the model itself. It might be some sort of adversarial attack. Can even be on the data input side, where you read your raw data from. Human in the loop can be part of this issue, and of course the infrastructure. Here, thinking about the provisioning as well of the model itself. So there are quite many different attack vectors, and I'm sure I'm missing some here as well. But just to show you a simple kind of example. But then when it comes to safe AI in itself, what do we actually mean? For security, we tend to talk about end-to-end security. But what would that mean for AI solutions? Can we really define something that encompasses the data input, the possibility of someone coming in and using an adversarial attack, human in the loop, but not just these type of issues. You also have the issue of the process itself that it takes. So today we have a process of mostly of collecting data and then using that data to train. Then you have the inference part, and then of course you need to be able to do forensics as well. So the forensic part is going to become more and more important. So if you have a vehicle out on the road and it makes a mistake, you really want to know it. How do you enable the police, for example, to use forensic techniques to go in and try and understand what's gone wrong? Currently, as far as the public media has reported regarding, for example, Tesla, then is that Tesla does this forensic report for them, for the police. I don't know if that is the way we should go. I think that if we get a regulation in Europe for AI, I would hope that regulation actually will demand that we have public officials that have the ability to actually do the forensic investigation. I think it's quite terrible if we outsource that ability to the same company that created the system. So safe AI is going to mean different things for many people. And then if we come into the reliability part, which I think is going to probably be even more important than just the security in itself, how do we define an end-to-end reliability for AI solutions? These are questions that I think are quite open. If you're looking for a thesis and trying to figure out what to do, I am not aware of a single paper that have looked at end-to-end security for AI solutions so far. What would it mean? Try and stake this out. I think it would be quite an interesting paper. It's something that I would personally like to read at least. And reliability may be more context bound, but still it's something as well that would be quite interesting. And then try and capture the different process parts that we have here. But if we look at an assessment of safety for AI, I've talked quite a lot about the data representation part. So claims of success for an AI is often dependent on a specific data set. That doesn't mean, of course, that it will actually be true in all other cases. If you transfer a model trained in the US to Europe, it may change. If you transfer it further to Asia, it may again change. So here, of course, is something that we really need to start to work on and try and gain some deeper understanding. In the medical field, particularly, this is something that is going to be quite interesting to see how you will prove that a data representation is not biased, that a data representation is usable between cultures, between countries, and so forth. So it's not going to be a very simple thing that you can do. There are some tools here, and this perhaps is more targeted to those of you with a computer science background. There are some interesting efforts being done within the data operations, data ops community. You can have a look at their manifesto. I think it's quite an interesting kind of way of dealing with versioning, and then not just the versioning part itself, but being able to show that you can actually prove that something existed, so to say. You can have some sort of sustainability in your system. Then you have the parameter evolution of models. Every time the data representation changes, we have to retrain our models, as I said, and that means that we have a situation where you would need to do a renewed assessment of your system. Now that may be quite expensive. It's not necessarily a very simple task in itself, depending, of course, on the use case. Here we have something called machine learning ops that you can have operations that you can have a look at. There's a link to a company there, Valohai. I'm linking to the company because this is the company their solution that we are using for our students. It allows them to keep track of their models. It allows them to build pipelines to more or less record what the accuracy of the models were for different parts, for different adjustments, so to say. But these two together, they both have similarities in the sense that they both have to think about orchestration. This is the way how you kind of set up your pipeline, how you define your environment, your compute environment. Unfortunately, these are also disposable environments, meaning that you start up an instance and then you throw it away, and you have no idea what you actually threw away. There's no way of getting that part back. So you may need to record quite a lot of metadata on these disposable environments. And then, of course, reproducibility, the ability here to actually go back over results and try to understand when, for example, you had an issue and why it propagated into to your production, all these kind of things. And then the monitoring part, when it comes again to production, you should be able to monitor what goes on and try to find certain issues that may happen, and this is something that is quite hard, I think, to do. So, for example, if you have someone that retrains the model, who is allowed to retrain the model, who is allowed to push the model forward into production? So all these kind of things should be of course monitored, and then once it's in production, you should continuously monitor the model itself as well, and how it performs against the unseen data, so to say. And sustainability in a greater in a general sense here, that we want to have methods, we want to have processes within the companies that allows us to actually exist tomorrow as well. We don't want to have solutions here where we had to kind of throw the company overboard every time there's an issue, so to say. Then we have model attack vectors. There are quite many interesting papers coming out on this type of with this focus. So you can have, depending of course on the modeling approach, you can attack both the train and the inference phases of a model. The earliest ones that were found was that you added simple noise to an image, for example, noise that a human would not understand that is there, and the model more or less gave a very different result at the end. So it's not enough to try and manually and visually inspect these data sets anymore. It's something that you have to really be careful in terms of if you use something that is out there. So for example, if you're working on medical data sets, and you buy your data from somewhere, you should be extremely careful in terms of how that data was prepared and how it was stored, and to be able to really show that it's not been tampered with. So then you have the scenario analysis, of course, that we talked about. Build these scenario analyses in terms of your use case, and try to figure out where they may be vulnerable. Then we have the decision space projections and the monitoring of those projections. Here we have, when we have more advanced solutions that combine a lot of different models, the output space for these decisions, it's not really known, and it's not possible perhaps to search the complete space either. So you cannot, for example, think again about the car here. You would not be able to test every single scenario that you can think of. So that means that you're going to push a model out into the real world that you have not verified. This is a rather big change from what we have had so far. I think most serious companies at least would try and test their software so well that you could argue that you know at least the majority of the outputs that the software is going to give. Then you have the organizational part, which is just as important. The design guidelines, checklists, maybe, but here, of course, one of the most important parts is that you empower individuals to raise problems, and that you track these problems. So and here I think we can look at the process for GDPR and the requirement for having a data protection officer in larger companies at least, that has a kind of an outside role of the business cycle, so to say, and has a responsibility then that is slightly different from what a business manager would have. And here the hope is then that that person would be able to escalate any problems that may occur. And then, of course, induce transparency over proprietary information. All of these companies that are using these systems, they are rather secretive of their models. They, of course, want to keep that secret. It's what gives them the competitive advantage. But that should not mean that it's only one person in the company that has an idea of what is going on. If you have that, then you open up the issue, of course, of using biased data to train your models or any other more or less ethical situation you can think of. So allowing at least some openness within that organization, some transparency in terms of modeling approaches is going to be quite important. As a summary, I would like to lift three main points. The AI systems, they do differ significantly from traditional IT systems. We are adding more complexity. We will, as a result, need renewed processes for maintenance, for security, for reliability. These processes are still, as I said, often on a research level, but still, I think it's going to be one of the fields that will grow probably the fastest in the coming years. Governance process for AI within the organization itself is key to address the continuous need for review. So within IT organizations, we had something called IT governance for quite many years, and it's a process that allows the organization to become more mature in a sense, to show maturity in particular. And I think that we have quite a lot to learn from that process when it comes to AI as well, where we can kind of formulate the certain principles that must be adhered to. And I think that with Roberto, you're going to hear more about the assessment part later on. So then you will have more information on what it means to introduce governance into the overview of the AI itself within the organization, AI development and use. So it's both an ethical and a technical perspective. But then, of course, at the end, we badly need new business models that incentivizes AI privacy. And here the incentive, having actually an incentive that gives the company a reason to protect privacy and trustworthiness in general. I think it's quite interesting to see what Tesla's been proposing. Again, I'm using them as an example. They have said that, for example, their self-driving car is going to be a subscription feature in the future. You're going to lease the right for having a self-operating car. And that's one way of course of going. It's something that we should consider, that we move over to the subscription model and try and not perhaps go the freemium model anymore. It feels, of course, hard on the pocket when you have to pay extra for something like this, but it might actually end up being what helps us at the end to actually get where we want to go towards the safe AI, the use of safe AI. So then I most certainly personally hope that AI is not going to be the new combustion engine that runs on our personal data. I think this is I think the whole discussion regarding data, personal data in itself, with those who claim that it was the new oil, so to say, I think that is really a bad analogy. It's not something that we should promote, so to say, further. Then should we define contract? So this goes back to the way we have defined contracts now again for GDPR. It was left quite open. So for example, if you use Facebook, they retain the right to process your personal information based on that you are under contract with them. And this is something that if I remember correctly, it's something that is being brought into the courts quite soon, and essentially meaning that is it enough to say that for any service? Can you argue with any service that we are working under contract, or should it require some sort of payment in order to address the freemium model here? So the freemium model or the free use for your data is what we are having an issue with, in a sense that they retain the right to use our data for more or less any purpose that they can think of. It's from a European point of view, it's quite clear that this is not the way we should go forward. But from a global point of view, I think it's undecided. I think that the business interest in the US has shown it's stronger than the privacy preserving kind of community. So we have to see how this goes. But personally, I think that it does need a payment in order to be a full-fledged contract. But let's see what happens in the courts, I guess. But thank you. This is the material I had. If you want to be in contact with me, feel free. I would definitely like to hear about if you're doing security for AI. It's something that is quite important, I think, and an interesting topic as well.
Okay, thank you very much, Magnus. We have here one comment question from Yvonne, so it's a bit long, but I'll try to read it. So monitoring a model should be accompanied by an ongoing statistical test. Is the model still in statistical footprint? Or that's quite a bit of an effort. If a model drops out of its footprint and must be retrained, how do you explain this to client using the model? He's expecting a certain behavior of a model. How can we be sure that model does not deteriorate in quality performance?
Yeah, I think this really hits the nail very well. It's something that we now are seeing with quite a lot of solutions that have been solved over the years that they use some form of AI. It's whether it's machine learning based or whether it's statistically based. And here, of course, you have to go back to and look at the data set that you used for training with or fitting with, and then try and see if the distributions are changing. Then you need perhaps to retrain. But I think as well that if we think about consultants have a very important role here in being able to help us go from where we are today, where we are kind of often a bit afraid perhaps of using models into then a more advanced setting where we can automate even more. And I think that consultants themselves should be honest with whoever they're selling their solution to. They should put a best before date on that model and say that, okay, let's say that in 1 year I will be back, and after that 1 year I don't take any responsibility anymore. Then it's your responsibility. If you have contracts that stipulate this very clearly, where the how long you guarantee a certain reliability, and if that reliability then would not be there, then you would have to go in pro bono, so to say, and retrain the model by yourself. I think this would signal to whoever is buying these systems that we can trust, that you will take care of the model itself. I mean, it's the same thing we do for almost any machinery today. We say that, okay, you have a service life of, let's say, 2-3 years, maybe more for certain appliances. I think we need to take that similar approach with AI solutions as well, and state out clearly that how long do we expect this model to be current.
Okay, thank you. Yeah, it's not an easy task to be solved, so let's see how it will go. I have probably a follow-up question. I was wondering, so you mentioned that company should not be responsible for this, let's say, AI safety inspections, and you mentioned also governments. So what do you think, what should be, like, do we need an organization, or who should be the one that creates these standards in towards trustworthy AI, and maybe who should check them really, both in company product level, also for services?
Well, I think it's anyone's guess what the regulation will demand, but I think that if we look at the white paper that was produced by the Commission, the EU Commission, at least for me, when I read it, I found that it was very similar language to the GDPR, meaning that it's most likely going to be a very open document that is, or very open legislation that is going to come. It will mostly be about certain moral aspects. And in order to interpret those moral aspects, it's most likely going to require some form of organization that can go in and define what we mean by safety. We already have this with, for example, cars, operating cars. Now they don't have perhaps an active role there, but there are the organizations that they can go in and assess, for example, whether or not the safety systems of the car, as we today define the safety system, brakes and so forth. Those type of systems, they actually work to a sufficient high standard. I suspect that this is coming for AI systems as well. The challenge here will be in terms of trying to generalize. So today, as far as we see, most organizations are trying to find their niche and trying to solve their use case. We don't really see, I think, on a general level. So here, remember the GDPR, it stands for general. So here, the basic idea is that applies everywhere. I don't know if we will get there with AI. Can we actually make it general? So that it would be a similar standard everywhere. I think it's going to be hard for them to at least to write any such proposal.
Mm-hmm.
But just to clarify, I think that what I was meaning, that there needs to be a public ability to do forensic investigation. I think that is what I wanted to say, that a police, for example, should be able to do the forensic investigation by itself. It should not be the company that created an AI that does the forensic investigation when there's an accident or an incident in general.
Okay. Thank you very much. So yeah, so for this inspections. Yeah, I think one other problem that I see there is the need of very qualified people who understand all this complex stack in the, I mean, all the things that you describe, especially in security. It makes it quite a complex system, so you need all these qualified people. So
yes, and if you remember, we don't have to go very far back in time. We can go perhaps 5-10 years back in time, and everyone that was working on machine learning more or less had a doctoral degree, or at least an advanced master degree in computer science or applied mathematics. Today, this has changed already. Today, we teach machine learning to bachelor students. I don't know if you heard about Elements of AI. It's a University of Helsinki created a MOOC, a massive online course for that I think been translated to quite many different languages. So that I think we are seeing now a diffusion of the what we mean by AI, but it's still I guess for most people it's magic, but then again, so it is for most machine learning people as well. It's still magic.
yes.
Many parts at least.
Yes. Okay, so yeah, I think with that we can conclude. So there is no more questions, at least I hear. So there are some comments, but I would say let's finish for today. And thank you once again for the very insightful and interesting presentation.
Thank you very much for having me.
Thank you, everyone, and see you next week.
Thank you. Bye-bye.
Bye.